Hello, good morning, good evening, good afternoon, wherever you are in the world. I'm not sure how long everybody was looking at me fumbling, maybe a couple seconds or so because I got an error on StreamYard that it wasn't going on LinkedIn, but now it is. Hope everybody's doing well today. My name is Michael Levan. I'm here with Nick Walker from StormForge and Patrick. Apologies if I get your last name mispronounced here from Kubecost. So we're going to be talking all things performance optimization, primarily around Kubernetes resources and cost optimization, which I kind of think, I mean, I'll get the opinion from you guys as well, but I feel like they very much go together. It's hard to have one without the other, I think, kind of more or less. Because from my perspective, if you're doing resource optimization, you're already hopefully saving money. And if you're not, the money that is being increased from a cluster perspective or from a resource perspective is necessary for the performance of the overall application stack, right? So sometimes it goes in the other direction, but that's because we need to scale up resources or whatever the case may be. So Nick, maybe you can kick us off from the resource optimization perspective and kind of how you see it fitting into the cost realm.
Yeah, definitely. So I guess I would just go back to what we see in sort of cost monitoring in general, which is just in a traditional cloud infrastructure, we saw people using VMs and they could easily see what a unit was. They could say, this team's using that VM of this size and it costs them this much. And then we brought in Kubernetes and it changed the paradigm, right? Now we've got a pool of VMs and people are sharing those resources. So an application runs on it, but it's using a fraction of that VM. And it's difficult to track. It's a difficult problem. And I'm sure PT could talk more about how they've tried to solve that.
Yeah, it definitely seems like the increase in hardship is there now, right? Because if we go back, just to the server realm, it was pretty easy, right? You bought the server, you saw the price, you know how much it was going to cost you. And then from a VM perspective, you were splitting up and separating resources within your server to create your virtual machines. But the cost factor, you almost weren't thinking about, like, because you already bought the server, you knew what that cost was going to be. So yep, the cost was out of the way. Now it's just a cost. Then it was just a cost perspective of like, okay, we have 20 VMs running, we can only add 5 more. Okay, now we need to buy another server, and then we had the cost thing there. But now in the cloud realm, it's the gloves are off and everybody's just kind of off to the races, because you can spin up something so easily, and then at the end of the day, you don't know really what that cost is going to be. Yeah, you can use some cost calculators and stuff, but at the end of the day, if you're scaling up, if you're scaling down, you kind of only have an assumption. That's like the best kind of thing that you can go with in the cloud. And then when it comes to Kubernetes, it's very much the same way. It's like the whole idea of Kubernetes is to scale up and scale down as needed. That's the ease of use from it, but it's sometimes a little bit rough on our pockets. So Patrick, maybe you can dive in a little bit from the cost perspective and kind of how you're seeing it in that realm.
Yeah, sure. So before I jump into that, I did want to touch on what you were saying, right? It's kind of this world that we came from, which was virtualization and bare metal before that. Really, it on-prem, right? The problems that we're trying to solve from a cost perspective in on-prem are different than in the cloud. On-prem, like you mentioned, we've already sunk the cost into your hardware or your dedicated virtual instances, and so that's more about optimizing for capacity, right? So that you can get more out of the dollar spent. Whereas on cloud, you're talking about reducing consumption as much as possible, right? So there's kind of those differences there from a problem approach. But from a cost perspective, right, with all these extra layers that you add on top, knowing how to kind of break those costs apart makes it much more difficult, more complicated, right? And so that's where we came in to kind of help devise some tooling to help you break it down, really all the way down to container level, if that's what you want to do, so that you can kind of subdivide your overall Kubernetes costs into smaller chunks, so you know what's making up that bill at the end of the month, and you can actually make decisions on a per application or a per team or a per deployment basis if you need to.
Right. Yeah, makes sense. And I think the problem is only getting harder to solve, I would say, right? Because, in the beginning, let's say, you had your application stacks, they were running in Kubernetes. Maybe you did a little bit of forecasting. So you had some ideas on, okay, these things, we're an e-commerce site, we're going to scale up a lot Cyber Monday and Black Friday. And then, we're in median for July to August or whatever it was, right? Like you could kind of get an idea of what your workloads were going to be based on how many sales were coming in, based on how many people were hitting the website, et cetera. So from the application stack perspective, it was getting, not simpler, but like you could have a better understanding of where the scale was going to be. Whereas now we're embedding everything in our Kubernetes clusters. So maybe we're running, cluster API workloads. Maybe we're running KubeVirt workloads. Maybe we're running a GitOps solution or whatever. So now we're taking our application stacks and those are still there, but we're adding these, third party resources in, which in turn are, of course, utilizing more resources. So now it's almost like we have to think about, okay, not only our application stacks, but when does this third party tool need to scale up? When does it need to scale down? And kind of manage it from that perspective. But you kind of also don't know what you don't know. So if you're bringing in a tool for the first time, things could probably get a little bit hairy, right?
Right. And then do you want to split the cost of that third party tool that's supporting your own internal applications, right? And if so, how do you do it? Do you proportionally? Do you do it, weighted somehow? These are all things that you have to decide, right? As you're kind of building out your Kubernetes based applications. So
yeah. And even, again, thinking about like, we're not just running containers on Kubernetes anymore. Now we have the ability to run, virtual machines. And we also have the ability to utilize Kubernetes for creating outside resources, right? So now maybe we're running something like Crossplane and it's like, okay, does this thing need to scale up and scale down based on how many resources are being created at once? If you're creating 40 resources at once versus if you're creating one resource at once, do you have to scale that up, scale it down? It's an interesting problem to solve. And one thing that I often think about as well, and Nick, I'll ask you this question and then we'll go back to Patrick here. Have we ever seen an instance where the cost went up significantly after cost optimization was implemented for a good reason, right? So like maybe you were just completely scaled down because you were trying to save money, but it was not the right thing to do and your application stack was not performing as expected. Is that something that you've ever seen?
I wouldn't say significantly, but definitely something I've noticed when we see people using our product is that there's usually 10 to 15% of workloads that are under provisioned, and sometimes quite a bit. And I think that that's kind of easy for it to persist because you've got the other 85% of workloads that are so over provisioned that they're creating this sort of buffer space on the cluster. And so it can go unnoticed. But definitely when you're talking about doing resource optimization, we're talking about right sizing. You need to make sure those under provisioned ones are set correctly, because if you start setting all your over provisioned workloads correctly, now you're talking about a performance and reliability issue.
Exactly. Yeah. And I want to touch on what you just said. And by the way, for everybody that's watching, we got a bunch of people in here. So please feel free to ask any questions at all. Nick is from StormForge. So, his world is revolved around resource optimization for everything Kubernetes. And Patrick is at Kubecost. So his whole world revolves around cost optimization. So if there are any questions, regardless of what platform you're on, we can see all the comments that come in from wherever. So definitely, please feel free to dive in and ask those questions. So I want to touch on what you said around right sizing, because I think that is, I often see when there are resource optimization and cost optimization tools implemented or practices implemented, the top thing on everybody's mind is, oh, we're going to save money, or oh, we're going to save resources, or oh, we're going to be able to scale this thing down. But that's not always the case, right?
Yeah, I definitely think that when people think they look at that word cost optimization, they think cost savings. And some executive banging on the table saying we got to cut costs.
Right.
But it's optimization's the key word there. There's parameters, there's constraints to optimization, and nobody wants to give up reliability or performance for cost savings. So you need the cost savings while keeping reliability the same, or even possibly improving it, like we were just talking about with bringing under provisioned workloads up.
Right. Yeah, and I've very much seen this as well. You know, I've seen various environments where it was like, hey, can we run, you know, one worker node at night or something like that to try to keep the cost down? And it's like, I mean, you know, there's a lot of things that we can do in life, but we probably shouldn't. and that's where the performance optimization piece comes in, and that's always been the biggest, most important part for me. Like any environment that I've ever worked in, it's always been about like, how can we make this thing run as effective as possible? Because we almost have to think about what's going to happen down the road, right? So yeah, you may be saving a couple of bucks now, but guess what? Your application doesn't perform as expected. Angry customers go to competitors, and then around and around we go. So it's like it actually falls more like more into the category of what can actually be the downside of this, aside from spending the money on extra workloads. What can kind of happen later on, and that's. I feel like that's not something that a lot of people think about, and it's something that we all kind of need to have in our heads, regardless of if you're in product, regardless of if you're an engineer building this. It's got to be something where it's like, what can happen in 6 months or a year, you know, from a performance perspective. And Nick, I know that's where StormForge can come into play from like an overall forecasting and stuff like that. And Patrick, I believe that there are forecasting capabilities within Kubecost as well, right? I'll kick it over to Patrick because I've been asking Nick a lot of questions.
Yeah. So, you know, forecasting, it's what it boils down to is, right, using the data from what you've seen in the past, you know, whatever time frame you want to look at, and then trying to make intelligent projections, right? We do it now in one of our latest releases, and we're kind of expanding on it. And it's all surrounding around like the dollar domain. And what I mean by that is like, and this is also kind of a good segue into how both Kubecost and StormForge work well together. So we focused on kind of representing all of our information in terms of cost. I say dollar, but really any currency, right? It all comes down to that, and that's kind of from a FinOps standpoint, kind of the finance folks. That's what the data, and that's the format, if you will, or the domain that they want to see. And then when you look at more on the IT side, they're more concerned with resource units of measurement, right? And that's really where StormForge does their part really well, right? So combine the two kind of, complement each other that way, right? And so our forecasting kind of shows the cost around, all right, here's the cost we've seen in the past. Here's where we think you're going to be going in the future. StormForge is an ML-based approach and kind of projecting resource utilization from what it's seen in the past. It's kind of that aspect of it, right? They kind of show the resource consumption domain, if you will. And so the two kind of work hand in hand together. You can do one, make a change in one and see the cost results in the other, and then kind of use that data to kind of reinforce the whole FinOps life cycle.
Sure. And when we're talking about forecasting, is there kind of a proper way to project the increase in a sense? So like what I mean by that is, let's say we have our forecasting for the past year, right? And we know, okay, we had high times here, we had low times here. This will give us an idea and an understanding for the following year. But hopefully you increase in traffic, you increase in customers, you increase in sales, etc. So if that's the case, that means the resources there's going to be more resources utilized the following year than the previous year. So that forecasting, it gives you an idea, but is there any way to kind of like know what the increase should be for the following year? So like if the projections are correct, we should be increasing the resources on our busy days by 3% or by 5%. I know like we can't answer that question for every organization because that would be impossible, but do you recommend any type of like quick math in terms of seeing what that increase should be?
I mean, from my perspective, if you feel like you've got predictable growth patterns, then you could probably use some kind of simplistic, math, just kind of linear regression type of stuff. But if you feel like your workloads are have a tendency to be unpredictable, or you just never know, right? If let's say you're an e-commerce business, and everybody knows about Black Friday, but what if you have some sort of flash sale or something like that, or a new product that you had never anticipated was going to be all the rage because some influencer just posted something, right? That's where ML comes into play, and it starts to learn and picks up and makes changes and updates its predictions much faster than something like a simple linear regression does. So so it like everything else in our space, it depends. And I think you have to know a little bit about your workloads and your business a little bit more than just before you can make a decision on what the right path is.
Right. Yeah. And I think that's a really, really good point, is that well, I feel like it's maybe always been this way, but it's being looked at more so now. As an engineer, you almost have to help make those business decisions. You have to kind of be, you have to have a seat at the table, so to speak, to give an understanding of, hey, look, like, this is what we utilized last year. These are the, projection of sales this year, or these are the, 3-4 days that we're going to have a flash deal, right? Like you were saying. So it's like, you have to be able to take those numbers and almost predict yourself what the workloads are going to be for the following year. And again, that takes more than just writing code to build a solution, right? It takes thinking about it, everything from a business perspective. So one more question for you, Patrick, then I'll kick it over to Nick. The same question that I had for Nick have you ever seen anything with Kubecost where it's like cost increased significantly because everything was so underutilized?
Yeah, again, I wouldn't say, just to kind of mirror what Nick said, I wouldn't say significantly, but we have seen where underutilization was identified, and we were, we showed them what they should potentially resize to, and then their cost did go up. But as a whole, I think it levels out because most of the other workloads, like Nick also alluded to, are usually over deployed, right? I mean, you mentioned earlier, again, we come from kind of the VM world before all this great Kubernetes greatness, right? Most of us just kind of came into this world with what we knew from virtualization, and so we sized our containers kind of accordingly, right? At least at the beginning. And those of us that have been in this space for long enough knew that was gross over deployment, or we learned along the way, and that's when we started looking for ways to optimize. So,
yeah, that totally makes sense. It's a weird, different world that we live in. And I think as Kubernetes kind of becomes like the platform of choice, right? If it continues to be the platform of choice, as we're adding things like virtual machines, as we're adding more third-party services, as we're adding more abilities to manage and create resources even outside of Kubernetes itself, it's going to be something where it could, increase resources drastically, or everything may be able to level out and, kind of meets somewhere in the middle based on what resources are needed to run various workloads. And you brought up a good point that I haven't thought about, and it makes sense. Yes, some workloads are increasing, but if the others are decreasing, hopefully you kind of like even out somewhere in the middle there, where you're not spending. It's like, oh, we have to spend an extra $5,000 a month on resources that wasn't in the budget, right? Like we all kind of don't want to hit that. But at the same time, if we do, right, if there's ever anything like a crazy amount like that, it's like, yeah, but what's the alternative? The alternative is to run resources underutilized and have customers go to a competitor.
Yeah, I think it's important to take the whole picture in, right? Not just like one specific app, because you don't even you don't like equalize. Usually you come out ahead in terms of cost when you do it for all of your workloads.
Right. Makes sense. So Nick, when it comes to StormForge, I know that we have the Applier where, hey, these are the recommendations for you. This is what we think we should run, right? And then you have the ability to kind of set the bar, right, in terms of for CPU, in terms of memory. Like, do you want it to be balanced, low, performant, etc.? Is there anything else that anybody can use when they're utilizing StormForge to kind of automate that process, like where they don't have to do anything, they kind of just let StormForge do it for them?
Yeah, so by default with StormForge, you install the agent, it discovers all your workloads for you automatically. That shows up, as you were saying. And then really from there, yeah, you can just choose to turn on auto deploy after you've looked at some workloads and you've verified that the recommendations make sense to you. So it can be as easy as that. And then, as you said, if you want to, you can go into each workload and you can look at configuration and you can say, you prefer cost savings or reliability. And that's actually something that I think about a lot, is just the trade-off between those two things. Cost and reliability are on a spectrum. And it's important that people think of it that way. It's like you don't want those cost savings without the reliability. You have to have reliability first, and we are just squeezing the cost savings out of the portion that doesn't affect reliability.
Yeah, and what do you think kind of got us to that point as a whole? Because I agree with you. Like, that's what I see a lot as well, where organizations are kind of like less almost concerned about the performance and the reliability and more about like that bottom dollar, because they want to be able to go back to the finance teams or their bosses or the C-levels or whoever and say, look how much money we saved. What do you think kind of transitioned us? And I feel like this is more of an opinionated question than anything else, but what do you think kind of transitioned us to the point of caring more about the cost savings than the actual reliability? Is it just because like we see the numbers in front of us on the portal and it's like, ooh, nice?
I think it's the story that we've been talking about. It was a lot easier to understand all this when it was bare metal in your data center. And then it got a little bit more complicated with cloud, but there's a lot of tools that came in and filled the gap and sort of helped you understand a little bit. And now you go into Kubernetes and it's really hard to understand what's going on. And it's really, really easy to scale. You just toss an HPA on your workload. You basically get the cluster autoscaler automatically. Maybe you throw a carpenter on there, whatever. And you can just grossly misconfigure how many resources you need for a workload. And then it scales to 40 replicas and you've got this huge thing that's taking up a lot of resources. It's just, I think when people looked at Kubernetes, they saw some advantages for developers, portability, developer efficiency, so on, like a centralized API that everyone could count on in Kubernetes. And they thought they were going to reduce costs. And they just got the opposite. They deployed their apps there, and suddenly the devs were like, great, this is great for reliability. I can just let it scale for me, and I don't have to think about it anymore. And cost just went up because it was no longer under the control of a team that could say, here's the thing you get, and you can use as much of it as you want. Now it's just, you have the credit card. You give your credit card to a teenager.
Exactly. Yeah. It's unfortunately, I think that was the story behind cloud in general, right? Like 2014, 2015, it was like, we get everybody off those servers in their data center and you're going to save a ton of money. And then now, as we're realizing, it's like, oh no, we are not saving a lot of money. We are probably spending, well, not probably, we are spending far more than we did in a standard data center. So speaking of data centers and virtual machines and stuff like that, Patrick, have you ever seen an instance where somebody was running Kubernetes on-prem, right, on a server, on virtual machines or whatever, and they were able to kind of, I guess, manage the costs a little bit easier? Oh, you're on mute, sorry.
I must have hit that by accident. Sorry about that. So I was saying, yeah, that's actually a use case, but of several of our customers, right? They still run on-prem. They run Kubernetes, whatever distribution or flavor that they want. But as we talked about earlier, it's more about, so while we kind of approach it from a cost savings, the problem they're trying to solve is more about how do they optimize their capacity, right? So, whatever their hardware refresh cycle is probably like 5 years, like most of the rest of those that are out there. And it's like, all right, I'm not buying any more hardware for 5 years, or it takes me 3 months to procure another box. Meanwhile, I got a project that's got a deadline coming up sooner than that. So how do I how do I break this thing apart so that I can make sure that I'm optimized from a resource perspective, so that I in turn get more workloads on the exact same footprint, right? And so, we'll have customers that will use Kubecost to kind of reduce their cost footprint per application, which in turn frees up more resources for new projects. And then what we, from a resource optimization standpoint, like what StormForge can accomplish something similar there, right? Where I think our strength shines in that problem that you described is you can leverage us for kind of internal chargeback, right? So now, we're making it so that you can be more optimized on-prem, but your app teams, now you've got the data that you can reliably use to then produce some sort of a chargeback so that you can actually get money back from each app team, or however you want to break up your organizations. Right. And then you can use that to kind of fund future hardware too.
Sure. Yeah, no, that totally makes sense. So one more question for each of you, because we're almost out of time here, but I want to ask one more question, and this is always a fun one. Start with Nick. Nick, what is the hardest problem that you've had to solve from a resource optimization perspective? It doesn't have to be the hardest. Well, maybe the most fun.
Yeah. I'll just go with I guess a recent one that I can think of. So, when we were looking at how we can help optimize with nodes as well, and so one of the interesting things that we found when we were looking in our own Kubernetes clusters, and then later looking at customer clusters, is just we go in and we can say cut the size of all the workloads by roughly 50% on average, and now all of a sudden we're letting the scheduler put those onto nodes, and we looked and we saw, oh, but the nodes are still not fully utilized. And the answer was, oh, all of these are hitting their pod limit. So nodes have a certain number of pods that they can fit on them. And by default, Amazon sets it probably significantly lower than it needs to be. And so the cluster autoscaler will add more nodes when it hits the pod limit of, say, 30 nodes or whatever. And so it's sort of an interesting problem is that I don't know that people know that they're scaling on nodes, or that they're adding more nodes just because they've run out of pod space, and there's a lot more room there. So we figured out how to get that increased, and Carpenter actually makes it really easy to get that pod limit increased, and then you could densely pack those nodes and get even more cost savings than before.
Nice. Very, very cool. Yeah, Carpenter definitely makes lives easier all around. It's awesome. Very cool. And Patrick, I'll come to you for the same question, except I'll ask, what's the hardest problem or the most fun problem that you've solved from a cost optimization perspective?
Yeah, so I think it's probably both, right? The most challenging and the most fun is this concept of when you break your cost down on a per team or per application basis, we're not just talking about cost running of the things running inside of Kubernetes, right? So especially if you're in the public cloud space, your app may be making use of S3 buckets, and maybe making use of EMR jobs, and maybe making use of like half a dozen other cloud native services. And so if you wanted to kind of represent a cost of an application, you usually have to include, or you would usually want to include, right, the cost of what's running in EKS plus the cost of these other, Amazon or Azure or GCP services, right? And you may be using services that are in a different cloud provider, right? They don't necessarily have to exist in the exact same cloud provider that your Kubernetes cluster exists, right? And so the ability to kind of string all those pieces together, or at least the shared components of those external costs, and kind of group them together along with what's running inside of Kubernetes, is kind of a unique thing that we do. And it's something that when I joined, when I saw it, I was like, oh, this is actually pretty cool, because I'd always wondered about, the total cost of something is more than just what at least it appears on the surface, right?
Right. Yeah, no, that makes sense. You don't know until you know.
Right. I mean, you touched on it earlier, right? I think a lot of us are if we haven't already learned, we're learning now that we're paying a premium to go to cloud. That's not necessarily a bad thing, given that you get plenty of benefits out of it, right? Namely, the flexibility and the ability to kind of just, spin up the new workloads at will. And a lot of us are kind of born in the cloud. Just that's the cost of us doing business, so we can roll that into whatever costs we need. But for kind of the companies that are out there that have been there for a while, that have moved into the cloud and need to kind of rein those costs in, you need all the tools you can get that kind of help you be efficient that way, from a resource and a cloud report or cost reporting perspective. So.
Yeah, no, I totally agree. And that's where something like StormForge comes in. That's where something like Kubecost comes in. There's no reason to guess anymore, right? Like there are so many tools in the wild that help with performance optimization that there's literally no reason to guess. And there's some that are open source, there's some that are enterprise, there's some that are a mixture of both. And yeah, no reason to guess anymore, folks. Don't guess. Just use the tools. Make your life a little bit easier. Awesome.
Totally.
Well, thank you so much, everybody, for listening and joining us. Really do appreciate it. Nick, Patrick, thank you so much for joining me. This was an awesome conversation.
Yeah, thanks for having us, Michael.
Have a good one.
Take care.